Tēnā koutou katoa. That means hello and welcome everyone in Indigenous people, the Māori. That is how they introduce themselves. Tēnā koutou katoa, welcome everyone. Today, I'm going to start the Lunar Marathon with the sort of semi-obvious link between the moon and the tides in the ocean. So, can you see the screen? Yeah. We have a history of tidal observations, and the tide, the word English tide, is derived from a Saxon word tid, or meaning time. And way back, people saw the regular cycles of the time. And some of those phrases were time and tide wait for no man, and what moon makes a full sea. So that's talking about the spring tide, or when the tides are much bigger. So a handy definition is that the tide is the regular rise and fall in sea level, and it's from the gravitational attraction between the moon and the sun. So the sun has a part to play on the Earth by distorting the ocean. So we're going to talk a little bit about how the moon distorts the oceans and gives us the tides. So one of the questions I used to get asked quite a lot, particularly from school children, was who generates the strongest pull on the tides on our Earth? Is it the moon? Is it the sun? And what role do the other planets play in those tides? Well, the moon has the biggest pull of all, and the sun, its average tidal force on the world's oceans is actually less than 50% of the moon's pull. And then the next biggest planet is Venus, and it's only 0.005% of the moon's pull. So virtually all the tides that we see on the oceans come as a combination between the sun and the moon. So the moon causes a distortion in the Earth's crust as well as the ocean. So we call Earth's crust, they're called Earth tides, but we're going to focus today on the ocean tides, and that's due to the gravitational attraction of that moon and sun on every part of the Earth. But as you will notice, at a coastal location, the tides can be quite different. And that's because the moon and the sun act on the deep ocean. And then it develops a tidal long wave, we call it. It's a wave that has quite high velocity as it moves into coastal areas, around continents and into harbors. And so it gets distorted and changed. So one of the myths around is that the moon has a direct gravitational pull that causes tides at any location. So if you see the moon above you, it should be directly pulling on the waters below it. But actually, that's not true. It's the differences between the forces that the moon and the sun have on different parts of the ocean. So if it's acting in one point at a high tide and another point it's a lower tide, that generates a wave between the high and the low tide. So that's what causes the tides at the coastal areas and the estuaries and the harbors that we see. Because otherwise, you would see a tide in your swimming pool or a small lake that's nearby. So we don't see tides in that because there's not a sufficiently wide ocean to develop a difference between the tidal pull of the moon or the sun. A second question is, why do the tides occur on average every 12 hours, 25 minutes, or during a day, 24 hours, 50 minutes? So there's a little animation, and it shows that the Earth spinning on its axis takes 24 hours, but the moon takes 29 days to get right round the Earth in its orbit. So every 24 hours, the moon has moved a little bit further along its orbit. And so it takes 24 hours, 50 minutes. So that's why the tide is not quite the same as our clock time. And some coasts have only one tide per day, and some have a mixture of tides. And so we're going to look at that in a little while. The next thing that's quite obvious in a lot of places is that when we have a full moon or a new moon, that's when the moon is lined up with the sun. So we get much bigger tides, mostly when the two are pulling together. But like tonight, when we're in a quarter moon, the moon is pulling one way and the tidal gravitational forces of the sun are acting along a different axis. And so they're pulling against each other. So we have smaller neap tides. We call the bigger ones spring tides and the smaller ones neap tides. The other tide that's really important is that the moon, during its 27.5-day cycle around the Earth, isn't a circular orbit around the Earth. It's elliptical and it's off center. So during that month, one part of its orbit, it's closest to the Earth, and we call that the perigee. And the other part of the orbit around the moon is the apogee, where it's further away from the moon. And when we have the sun, which is in a new and full moon, at the same time as the perigee, where it's closest to the Earth in its orbit, we have what we call king tides or perigean spring tides. So some of you will be familiar with the phrase king tides, and they are big tides that cluster every 7 months. Then they wane and then they build up again in 7 months' time. So that's when everything is pulling together. We call them king tides or perigean spring tides. I'll just show you some tides from New Zealand, because we have some fascinating tides that go around New Zealand. So on our east coast, we have the perigean tide. So P was when the moon is in its perigee. That's when we're on the east coast, we get the bigger tides. And then a month later, we have another big tide. Whereas on our west coast, we have new and full moon, and we have that nice regular spring neap cycle in the tides. So we have quite different tides on the east and west coast. Looking globally, this is the average twice daily tide that the moon causes on our Earth's oceans. And so you can see that it is very complex. So that's why if the moon was above a certain part of the ocean, it's not the direct pull, but it's the changes in the moon's forces on the deep ocean that then move into shallow areas and around continents. I'd like to particularly highlight that there are large tides where it's red and smaller tides where it's blue. The other fascinating thing, and New Zealand is one of these, is that the tide spins around New Zealand every 12 hours and 25 minutes. So that's one of the areas where we have a tide that spins right around for each tidal cycle. The only other part of the world where this happens around a continent or a piece of land or a landmass is in Madagascar, where the tide moves around Madagascar over 12 hours and 25 minutes. So just to give you an example, this is the tide, the lunar tide, twice daily tide that goes around New Zealand. And the blue is the low tide and the red is the high tide. So it spins around New Zealand in an anti-clockwise cycle. And so that means anywhere at any time, there's a high tide and a low tide in New Zealand. And so that's another reason why, sure, we have the moon above us tonight, but it's not pulling directly on the water around New Zealand. And that's because it's operating on the deep oceans, and then it propagates and moves around in a circle. So when we put that in a co-tidal map, this is what we call a map of co-tidal. It's the lines join all the time, all the places around New Zealand where the tide is occurring simultaneously. So each line has a high tide that occurs at the same time. And the color is the half range or the amplitude of the tide. So we get big tides on the west coast and smaller tides on the east coast. Different parts around the world, as I said before, some of them only have one tide per day, and that's called a diurnal tide. Fremantle in Australia has these single tides per day. Other places like the west coast of the USA and Canada, and San Diego is an example, where they have a mixture between a once only tide and a twice daily tide. And then in Auckland in New Zealand, we have twice daily tides. Just coming now to that explains tides, but we need for our sea level to see tides are only one contributor to the sea level that we observe at the coast. So there can be waves, swell, there can be seasonal effects, there can be storm surge. And tides operate from 1 hour cycles right through to 18.6 year cycles when the moon goes through its what we call nodal cycle. So tides combine with these other things and they can cause coastal flooding and issues with sea level rise. So I'm just going to touch on two, one combining with storm surge and one combining with sea level rise. What we do in New Zealand is we have a red alert tide calendar. This is solely the times when we get king tides or perigean spring tides. So the dark red are the dates in New Zealand when in 2021 we get the top 15 tides. And the reason we issue these as red alert days is because when the tide is very high, it only needs a very small storm surge in New Zealand for it to become overtopping and cause coastal flooding. So we say to managers on these days, put them in your diary and watch out for the weather, watch out for the waves, because it could be very easy to have coastal flooding during those red alert days. So they're the king tides. The light red are reasonably high tides, and the blue ones are when the tide is quite low. With sea level rise, we can look at storm surges, whether they occur once a month, right up to once a century. But as we raise sea level, then the tide's right on the top of the mean sea level. And so everything is riding on the top of that. So we can get something that used to occur once per century with a rising sea level will occur once per year or more frequently. So that's, we're seeing 3.2 centimetres per decade at the moment. And what I'd particularly like to end with is we're starting to see tides creep onto the land, what we call during sunny day flooding, when perigee spring or king tides occur. And I'll just end on this, a couple of pictures, one from New Zealand, one from Miami. The tides increasingly will be seen on land due to sea level rise. So on the left here is an estuary, it's brim full, and that's during a king tide, but the sun is out and there are no storms. Similarly for Miami, they're seeing more increasing sunny day flooding when the tides are very high on king tides or spring tides without any storm surge in sight. And that's because the tide is now riding on the back of a rising sea. So that completes my little talk on tides. So I'll hand over.